Hello everyone. In the last video we talked about, I not only introduced oxidation and reduction reactions or redox reactions, but we also talked about oxidation states, rules or oxidation states. So what I want to do is just go over this again and then jump into how we apply those rules when we actually talk about redox reactions. So again, an oxidation or anything that goes through oxidation or is oxidized, it's lost electrons. Okay? Now, since these two processes have to happen at the same time, oxidation and reduction, they have to happen at the same time, the electrons are going to go down here. So that means that something is reduced if it gains electrons. We have our two mnemonic devices where Leo the lion says Gura, and again that's lose electrons is oxidation, gain electrons reduction, or oxidation is losing, reduction is gaining. Okay, so those are those two. Oxidation reduction, you notice that we did this already. Let's go to this where we actually write out redox reactions. Okay, what's actually happening? What's getting oxidized? What's getting reduced? Okay, so let's do this. The first thing we have to do when we come to these is look at the oxidation states or oxidation numbers. So for aluminum, that's a 0. It's in its elemental form. Iodine, that's diatomic. It doesn't matter. It's still in its elemental form. It's just iodine. It's just aluminum. Next, let's go over here. This is a monatomic ion. This is a monatomic ion. It actually works out perfectly. Aluminum in its normal oxidation, excuse me, its normal charge is +3. Iodine's -1. Okay, the numbers work out perfectly as well. If you notice that -1 times 3 is -3. +3, works out perfect. Okay, so what got oxidized and what got reduced? Okay, aluminum goes, I always looked at the thing that gets more negative, okay? I went from 0 to -1. Iodine, got reduced. Whereas aluminum got more positive or less negative, or it lost negative things, so it got oxidized. Okay, that's one example. If you want to pause the video and try the next one, I'm going to start on it now. Okay. All right, let's look at this one real quick here. Notice stoichiometry doesn't play a role here. Okay, at least not yet. Okay, oxygen, that's elemental, that's 0. PbS, that's lead 2 sulfide. And now Pb is a monatomic ion. Sulfide is a monatomic ion. It's an ionic salt, so that makes it easy. So this is -2, and this is +2, okay, according to their ionic charges in Rule 2 from our oxidation rules. Okay, looking on to the product side, same thing. This is -2. This is +2. Okay. Now again, if I do the math, it simply works out to cancel each other out because they match. So no big deal. I don't have to go any further. SO2 is a little bit different now. Oxygen, it's not oxide, it's oxygen. This is SO2 because now I have a covalent bond or a molecule here. No salts, no ions. So oxygen is -2 most of the time. It's a pretty electronegative atom. But there's 2 of them, so it's -4. That means the missing number is +4. So +4 is distributed over just this single sulfur. That's +4. Okay. So what got oxidized? What got reduced? Well, we don't have to do this, but you can actually ignore lead. Just be careful in crossing them out because sometimes they do. It gets a little funny. But lead doesn't do anything in our redox reaction. Okay. Sulfur, though, actually, let's go to oxygen. Oxygen not only got more negative here, but also got more negative here. So oxygen definitely got oxidized. Shoot. Got reduced. Excuse me. It got more negative. It got reduced. Therefore, sulfur must have gotten more positive. And if we take a look, it did get more positive. It went from -2 to +4. That got oxidized. Okay, sorry about that little goof. Okay, and the last one right down here. Okay, no rule for carbon. Let's take a look at this right here. This is something called methane. No rule for carbon, but hydrogen gets +1 again almost every single time. So that's a +4 charge. The number that's missing is -4. So carbon this time, wow, that's weird. It's -4. Okay. Oxygen or O2 is elemental, so that's 0. Carbon dioxide on the other side, again, no rule for carbon just yet, but this is -2, but there's 2 of them, so that's -4. The missing number is +4. It's got to equal 0. So this is plus 4. I'm going to erase this, just it's getting in the way. Negative 2, positive 1, those are the rules, and they apply, and the math works out perfectly. You can prove that on your own if you want. So what happens here? Let's see, carbon goes from negative 4 to positive 4. If you go from negative 4 to positive 4, that means it got more positive. So when things get more positive, it means it lost negative things or lose electrons. This got oxidized. Okay. Hydrogen went from plus 1 to plus 1. It's not doing anything, so we'll ignore that for now. Oxygen went from 0 to negative 2. That got, in both cases, actually, you see 2 negative 2's over there. So oxygen went from 0 to negative 2, got more negative. It got reduced. So oxygen got reduced, and carbon got oxidized. Okay? All right. That's all I got for that. Again, see you in class.